Clark here with Simpson Math. Shout out to followers of Neb Khan for this Trinity College cap. Thank you very much. It makes me look a little smarter than I am. I really appreciate it. Okay, today we're going to talk about graphing sinusoidal waves, by seeing in an expression like this one of our double angle or possibly half angle identities. So my first example here is, wow, I don't know why this is so far away. But anyway, we have this expression here, and it almost looks like a double angle for cosine. Let's see, can we see that in the screen? Oh, there we go. So we want to graph this function here, and if it was 2 cos squared minus 1, we would have cos of 2x, which would be easy to graph. Of course, it's not 2 cos squared minus 1, it's 4 cos squared minus 3. But wait a minute, let's rewrite this as 4 cos squared x minus 2 minus 1. And then let's factor out from this binomial a2. You'll see that if I factor out from that binomial a2, I'll have 2 cos squared x minus 1. Now I still have this one, okay? But in here we have a double angle for cosine. So we have 2 times cos of 2x, because this expression here is equivalent to this by the double angle. And so we just have a dilated cosine wave, dilated, whose frequency is 2 and its amplitude is also 2. It's been amped up some and then it's shifted down 1. I'm going to graph just this first, then we'll move it down 1. So in smoke, I'll graph y equals 2 cos of 2x. So that means the amplitude is 2. So I would go to 2. And I would go to negative 2. Can we see that all on the screen? Maybe I need to. Okay, there we go. So I'm going to make my amplitude 2. And so that means it's going to have a maximum of 2 and a minimum of 2. Its frequency is 2, so that's going to affect the period. The period of this graph is the usual period divided by this frequency of 2. So that's pi. So my period should be pi, meaning I should finish a complete cycle over an interval on the x-axis is pi units long. So I'm going to start my wave. Cosine starts at its peak, so I'm start at 2, go to 0, go to negative 2, go back to 0, and then end up back at its peak. And a cosine wave looks like this. And there we have this graph. Its period is pi, its amplitude is 2. And we'll label these, if this is pi, this is half of pi, and this is a half of pi, which is pi fourths. So that's 1 pi fourth, 2 pi fourths, 3 pi fourths. So I have my axes labeled. This is obviously 1 and negative 1. And now what I want to do is graph this function here. And I'll do it in black. And so I'm going to graph y equals 4 cos squared x minus 3 was the original problem. But remember, it's equivalent to this. So, which is equivalent to the smoke curve shifted down 1. So I'm just going to take this smoke curve and shift it down 1 unit. So this point's going to come down 1 unit. This point will come down 1 unit. This point will come down 1 unit. Can we see that on the graph? And so that means I must be down here at negative 3 now. This point will come down 1 unit, and this point will come down 1 unit. And the x-intercept must be somewhere before pi fourths. And the other one must be somewhere after 3 pi fourths. And if we need them, we could set the function equal to 0 to look for them. That's how you graph this original function. You take advantage of the fact that it looks like it's very close to a double angle. Now let's do one more example. Here we have y equals 8 sine x cos x. And if only this was a 2, well, we can factor it out. We could factor out a 4, and then we would have 2 sine x cos x. And so now we recognize that this is the same thing as sine of 2x. So once again, my frequency is 2, which is going to make my period pi. Okay, if my frequency is 2, then the usual period of 2 pi, you divide by this frequency of 2, you get 1 pi. So my period should now be, pi, which makes this halfway. So it's pi halves, and a half of a half is a fourth. So this is 1/4, 2/4. This will be 3 pi fourths. And then let's see, my amplitude is going to be 4. So I'll make this 1, 2, 3, 4. So this is -4. Now sine starts at 0. So it starts at 0. It goes to its peak, which is now 4 because the amplitude was changed. Then it goes to 0. Then it goes to its peak, and then it comes back to 0. And the sine wave looks like this. And so this is y equals 8 sine x cos x, which is equivalent to 4 times sine of 2x. Math made simple, Simpson math.